Hello, I welcome you all to this another interesting screencast, and the problem reads: a 25 kg bar has a center of mass at G. If it is supported by a smooth peg at C, a roller at A, and a chord AB, determine the reactions at these supports. This problem is coming from the Engineering Mechanics Statics textbook, 13th edition by R.C. Hibbeler. So we have a 25 kg bar that has a center of mass at G. And if it is supported by a peg at C, a roller at A, and a chord AB, so let's first and foremost draw the free body diagram. So let's section the chord there. So we are going to have a tension force T, okay, and then we are going to have here a normal reaction force at C in that direction, like so. All right, so let's call this as our C, okay. And we know the angle, this angle here, we've already been given this angle here. If we were to draw this angle like so, we already know this angle here. This angle here is equal to 30 degrees. This one here, it is 30 degrees. Right. What else? So maybe I just write it inside this angle. So this is the 30 degrees. Okay, this is 30. Great. So let me just get, alright, this is not fine enough. Alright, that is 30, like so. So we are going to have two components there, but we'll indicate them later on. We are going to indicate them later on. Then we have another force here, which is the weight. We have a weight here. Let me show it like this. We have the weight. Let me show it in black. Okay, let's say we have the weight. It goes out like so. And the value of this weight is 25, that is mg. 25 times 9.81, that is the acceleration due to gravity. So we have 25 by 9.81. So this gives us a 245.25 newtons, right? 25 by 9.81. Okay, 245.25. Right. What else? So, and then here at A, we are going to have the reaction force in the vertical direction. We are going to call AY. So this is what we have at the moment. We need the components of this particular force. We need the components. So we need this force in this direction here. We need them as we begin to take moments. Let's say about A. So we're going to need components, a component in this direction for this one. We already know what this angle is. This angle here is a 30. Okay, this is a 30. So this one is going to be equal to a 245.25 cos 30. Then we'll have another component in this direction, another component in this direction, which is going to be equal to, this one is going to be equal to 245.25 sine 30. Alright, so for now we can take moments about point A so that we find C, and once we found C, then we are going to later on write the components of T and the components of C. Alright, is that fine? So let's say summation of moments about point A equal to 0, and clockwise being our reference. What do we have? So summation of moments about point A, we have a clockwise moment which is a 245.25 cos 30 degrees times 0.5. Alright, and then we have plus C times the lever arm, which is equal to 0.5 plus 0.2 is 0.7, right? Then equal to 0. Okay, the tension about A will be equal to 0, and the component of the weight also will be equal to 0. Great. And then what do we finally have? Therefore, our C is equal to, let's find what C is, minus 245.25 cos 30 times 0.5 divided by 7. So we have a 151.71, okay, 71 newtons. All right, so minus 245.25 cos 30 times 0.5 divided by 0.7, 151.71. All right, then let's apply the equations of equilibrium in the y. Let's get the other components. So C will have two components. It will have one component in the vertical direction, this one. So this one is equal to C cos 30, and it will have another one in this direction. This one is equal to C sine 30, and then T also will have two components. It will have this component. This one is T cos 15. Okay, and then it will have another component which is this, and this is T sine 15. Great. Of course we said this is AY, right? This is AY. Great. So summation of forces, therefore, in the X direction, which direction do we start? We have C. How many do we? So we have only T, that is unknown. Alright, it's fine. Summation of forces in the Y is also fine because we found C, so it's fine. So summation of forces in the Y equal to 0, going up in our reference. So we have T sine 15 plus AY. No, we have to start with summation of forces in the X. Sorry. So summation of forces in the X equal to 0. Okay, we have less unknowns. We have T cos 15, then minus C sine 30, and then what else? These are the only two components in the X direction, right? Yeah, equal to 0. We already know what C is, so we can get our C and plug it there so that we find what T is. Our T therefore is just going to be equal to 151 times sine 30 divided by cos 15. So we have 78.53 newtons. So 151.71 sine 30 divided by cos 15, 78.53. Alright, then finally now we can go in the other direction where we have the rest of, we only have in that case now There we have AY that we want to find. So we have AY plus T sine 15. Then we have minus 245.25, then plus C cos 30 equal to 0. So we have T we just found it as 78.53, and we have C which we just found as 151.71. So once we replug them back in our equation, this gives us 78.53 sine 15 minus 245.25 plus 151.71 cos 30. We have AY equal to 93.54 newtons. Let me just get back again. 78.53 sine 15 minus 245.25 plus 151.71 cos 30. 93.54. Great. So let me write these solutions. We have AY equal to 93.54 newtons. Then we have T, which is equal to 78.53 newtons. 53 newtons. T also here is equal to 78.53 newtons. Then we have C. We have C which is equal to we have C. We said C here is equal to, we found C equal to, where is C? C is equal to 151.71 newtons. Then let's outline the solutions. We have C, which is the normal force at the peg. We have T, which is the tension in the cord. Okay. And then we have AY, which is the reaction force at the roller. Okay. So this is really about it. And I hope the video was helpful. If it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and see you in my next screen.